Next example comes out of section 7.2, transformations of exponential functions. So in this question we're told that water is heated up to 100 degrees Celsius and then it's set to cool in a room at 20 degrees Celsius. The graph looks something like this. We've got temperature on the y-axis, time on the x-axis. Starts at 100 degrees and starts falling and approaching 20 degrees. We're also told in the question that it's approximately the temperature decreases about 25% every 5 minutes. In some previous examples, we've seen bacteria populations growing exponentially. We've seen radioactive materials decaying exponentially. And again, the exponential model is just that. It's a model. For this example especially, the graph is approximately the shape of an exponential curve. And so we can come up with an equation that fits it. And the fact that it decreases by 25% every 5 minutes means we have 75% of the temperature we used to have every 5 minutes. So the base of this exponential function is going to be 0.75 minus 0.25. If I use m for minutes, because I want t equals, we can say, well, divide your number of minutes by 5, and that'll be the number of 5-minute intervals that you have. We can see also just from the graph that it appears to have been moved up 20 units, so plus 20. And we might search for what this a value is. The graph hasn't been shifted left or right, but it does appear like it's been stretched. And especially if we take in and put in when minutes equals 0, the temperature equals 100, we can basically solve for what a has to be. So 100 equals a times 0.75 to the 0 over 5 plus 20. 80 equals a, because 0.75 to the 0 is just 1. So the equation that models this the best, given what we're given in this question, is 80 times 0.75 to the m over 5 plus 20. If this were an exam question, I would make sure the model is a little bit better fit, but this does work for an example. Basically what we're going to be asked here is describe how in the generalized equation of an exponential being y equals a times c to the b x minus h plus k. Describe how the a, b, c, h, and k relate to the situation above. In this case, the a which was 80, which is the temperature difference between the 100 degrees that it started with, 100 degrees to start, and 20 degrees to fall. To fall 80 degrees to 20 degrees, so that's where the 80 comes from. Now the b is 1/5, because we said what to do m divided by 5, and we did that because of the fact that it was every 5 minutes that they gave us in the part of the question or the example where it said every 5 minutes it decreases 25%, which also explains why this base is 0.75, because it's decreasing 25%. If they would have said decreases 10%, we would have had a base of 0.9. If they would have said every 2 minutes, we would have had 1 over 2 instead of 1 over 5. So you can kind of translate things that you know into this equation. The last one, well, h is 0 because we're starting with time equals 0. It doesn't make sense to move it left or right. But the k value being 20 relates to two things. First of all, the asymptote up above was 20, so that tells us right away that this graph had to be moved up 20 units. But it also, again, relates to the final temperature. The lowest this thing could possibly drop is to 20 degrees Celsius. It makes sense for water sitting in a room at 20 degrees to fall below 20 degrees. It's just not going to turn into an ice cube in the middle of the room. So there's not so much an example question that I think you'd see on a test, because we would ask some component of that, but it's a useful teaching example anyway.